All right, Math 043 students, this is the section 11.1 quadratic functions and their graphs notes. We should have covered this on Wednesday's class, and this is the video to make sure that we don't have so much to do on the last day of notes, which is Monday before our final exam, which is going to be this coming Wednesday. So we're going to talk about how when we talked about first quadratic equations, we learned that in standard form, kind of when you're factoring them, they look like ax squared plus bx plus c, and if it's an equation, we had it set equal to 0. A quadratic function is just setting that 0 instead, saying it's the function notation f of x. So the graph of any quadratic function is what we call a parabola, which is a U-shaped graph. The vertex is the lowest point if your parabola is opening up, like an upwards U. If your U is upside down, then the vertex becomes the highest point on the graph because you're opening downward. The graph is symmetric with respect to the y-axis if it has not been shifted at all. If it has been shifted off of the kind of y-axis, in other words, the vertex is no longer on the y-axis, then the axis of symmetry will be a vertical line that cuts your parabola in half. So that is something we're going to be asking about in some of our questions. So we'll have to figure out how to find that. So the first thing is we want to look at these pre-graphed equations, and we want to find the vertex, the axis of symmetry, and we want to talk about whether the parabola opens up or down. So the vertex in this one would be the lowest point right there. So my vertex, which we usually just call V, is -2 for x and -1 for y. Your axis of symmetry would then be a, remember, dashed line, which is hard to do with this ink, that goes through that vertex. That is a vertical line, x equals -2. So that's my axis of symmetry. And then this graph opens up because it looks like a normal U shape. Okay, so let me see if I can thin out this marker just a little bit. Okay, this one, the vertex is the highest point, and so it is at the ordered pair 0 for x, 4 for y. The axis of symmetry would be the y-axis here, because notice it is completely symmetric across that. So if your axis of symmetry is the y-axis, that is the vertical line, x equals 0. Remember, vertical lines are x equals, horizontal lines are y equals. And then this one opens down. So this is just so we can recognize the vertex, see the axis of symmetry, and also determine what opens up versus opens down means graphically. Okay, so if you wanted to have an equation or a function that is quadratic given to you and you don't have a graph of it yet, but you want to know where the vertex is, there is a formula that allows us to find the vertex. So this is our steps that we will use to find the vertex of a parabola if it's written in standard form. You first find your x-coordinate of your vertex, that's this first part of the ordered pair, by plugging the a and b, remember those are coefficients from up here, into the formula x equals -b over 2a. Now this is going to be really important in Monday's lesson because we're going to learn about the quadratic formula, which does include this piece of it. So x equals -b over 2a, you plug in the numbers, you find that number. To find your y-coordinate, you have to find whatever you got for x and you plug it into the equation to get your y. So that's how you get your vertex ordered pair. So we're going to practice that. So we're going to find the vertex of the graph of this function and support our answer graphically. So we're going to show that it is actually correctly graphed. So let's do, so let me write my function down. So f of x equals 2x squared plus 8x minus 3. So we want to do x equals -b, which would be -8 over 2a. So this is -8 divided by 4, which is -2. To find our y-coordinate, we have to put -2 into the function. So this would be 4 times 2, so that's 8. -16 minus 3, that is -8 minus 3 more, or -11. So it looks like when I graph this, my vertex should be at -2, -11. Now let's support it graphically by doing a table of values, and we're going to put -2 in the middle of the table. We already know the answer is -11. What we want to prove is that this actually is the lowest point on our graph because this has a leading coefficient that is positive, which we'll define in a minute, means that it opens up. So I would pick two numbers smaller, two numbers larger, and we're going to plug them into our function. So f of 0 is really easy to evaluate. That would just be -3. The others you'll want to show work for. So plugging in -1, that would be 2 minus 8 minus 3. So 2 minus 11 is -9. Plug in -3, that'd be 2 times -3 squared plus 8 times -3 minus 3. 9 times 2 is 18, minus 24 minus 3. That's 18 minus 27. That is -9. And plug in -4. 2 times -4 squared plus 8 times -4 minus 3. That's 16 times 2, so that's 32. Minus 32 minus 3, so that's just going to be -3. If you have done this correctly, if you've got the right vertex, this will always happen. The y values on either side will have symmetrical values. That's because the parabola has symmetry. So if we go left 4, down 1, 2, 3, and then left 3, down 9, which I believe was this one. Left 2, down 11, we have to add 1 for 11. And then we have -1's down at 9, and 0 is at -3. So notice I get this nice symmetric parabola shape opening upward, and my vertex is the vertex. I was correct finding it this way because there's no points lower than that on that graph. Okay, so if you want to graph any parabola that's given to you, the first thing to do is determine if your graph opens up or down. So if the leading coefficient is positive, the parabola will open up like a regular U. If the leading coefficient is negative, your parabola will be upside down, essentially, so it opens down. Use the vertex formula to find your vertex, create the table of values around the value of the vertex, just like we did, graph all your information, and draw the parabola. So we're going to practice some more, just graphing these. It says identify the vertex and the axis of symmetry on the graph, then graph it. So first let's do our vertex. So this one does not have a b. So if you need to rewrite this guy so you can see it, it's 0x minus 2. It's missing that term. So when I go to find my vertex, x equals -b over 2a, that's just going to be 0 because 0 on top is 0. If I plug 0 back in to my function, I get 0 squared minus 2, which is just -2. So my vertex for this problem is at 0, -2. That means my axis of symmetry, which I'm just going to abbreviate that way, is also happening at that x value of 0. So we don't have enough to plot the whole thing, remember, because you need a few points. So we're going to put 0 in the middle of our table with the -2 we already know. Then we're going to pick -1, -2, and 1 and 2. So technically, if you know for sure you've done the vertex right, you only need to do one side of your table because the other side should, remember, have that symmetry. So f of 1 is 1 squared minus 2, that's -1. F of 2 is 2 squared minus 2, which is 4 minus 2, so that'd be 2. So we should get the same answers here, so I'll show that. F of -1 is, remember, it's -1 squared minus 2. So that's going to be 1 minus 2, which is -1. And f of -2 is -2 squared minus 2, which is 4 minus 2 again, which is 2. So that does make this look like it's supposed to look. So -2 down, or excuse me, -2 up 2. And then we have -1 down 1, 0 down -2, 1 down 1, and 2 up 2. Then we draw our nice parabola shape. And notice this one does open up because we had that leading coefficient that was positive. We could know that before ever doing anything else. All right, let's try another one. So this one's a little more involved because we do have all three terms. Actually, I skipped one, sorry. We have this -1 in the middle. Okay, so if you're in this format, there's actually a way to graph this. We haven't learned it yet. It's called vertex form, and that's something we cover in 136. You could graph it from this form if you know the pieces, but the leading coefficient is negative. So A is negative. That means we're going to open down. That's important to note. And I didn't put the axis of symmetry on this one, sorry, did I? I think I did. Yes, we did. Okay. So then when we do this one, I would probably distribute or FOIL this out because we don't know the vertex form yet of how to use a shortcut to graph this. So we need to do x minus 2 times x minus 2, which is x squared minus 2x minus 2x. That'd be minus 4x. Negative 2 times negative 2 is positive 4. So another way of writing this specific quadratic is to distribute that negative, and we get the following. So negative x squared plus 4x minus 4. So if we want to do our vertex form, we need to do x equals negative b, which would be negative 4, over 2a, which is a negative 1. So this is negative 4 divided by negative 2, so that's 2. Then we have to plug into to get, and you can plug it into the original if you want, to get our y value. So this is negative 0 squared, which is just going to be 0. So my vertex is at 2, 0, which means my axis of symmetry is x equals 2. We want to do a table of values to find some extra points, putting our vertex in the middle. So we want two numbers smaller than 2, so 0 and 1, and two numbers bigger, which would be 3 and 4. Let's just plug, and again, if you want to plug into the trinomial like this, or if you want to plug into the original, either one's fine. We just had to have the trinomial to be able to find the vertex formula because we needed that b term. So if we plug into the original, this would be negative 0 minus 2 squared. That is negative 4, because you square this, but then you have the negative out front. Negative 0, or excuse me, 1 minus 2 squared would be negative 1 squared. You square negative 1, you get 1, but you have the negative out front. And then negative 3 minus 2 squared is going to be a negative 1 again. And negative 4 minus 2 squared is 2 squared, which is 4, but there's a negative out front. So 0, negative 4 is one of our points. 1, 2, 3, 4. 1, negative 1. 2, 0. 3, negative 1. And 4, negative 4. So notice this is a parabola that is opening downward. Okay, and then the last one in this little section before we talk about maximums and minimums is this trinomial right here. So does it open up or down is the first thing we want to do. Sorry, that thing keeps popping up. This is a positive leading coefficient. There we go. It's not liking me right now. So this is a positive leading coefficient greater than 0, so that means we're going to open up. We need to find our vertex. It's already in standard form, so x equals negative b, so negative negative 2, all over 2 times a. So this is going to be 2 over 2, which is 1. And then we want to plug 1 into our function to get the y value. 1 minus 2 minus 3, that's going to be negative 4. So the vertex of this problem is 1, negative 4. The axis of symmetry would happen at x equals 1. Because remember, it's always wherever that vertex x coordinate is. And then we do our table of values. So this is 1, negative 4 goes in the middle. That's our vertex. So we need 0 and negative 1 for smaller and 2 and 3 for larger. So if we do f of negative 1, that is negative 1 squared minus 2 times negative 1 minus 3. So that's 1 plus 2 minus 3. That's going to be 0. F of 0 is 0 squared minus 2 times 0 minus 3. So that's just going to be negative 3. F of 2 is 2 squared minus 2 times 2 minus 3. So that's 4 minus 4 minus 3. So you're seeing a pattern here. And f of 3 is going to be 3 squared minus 2 times 3 minus 3. So that's 9 minus 6 minus 3. That is 0. So if we've got our vertex right, you see this nice, lovely y value pattern every single time. So negative 1, 0, and then 0, negative 3, 1, negative 4, 2, negative 3, and 3, 0. And draw the best curved parabola that you can. Okay, so even though we haven't defined the vertex as a minimum or a maximum, it essentially is, because if you have a parabola that opens up like this, then the vertex is the lowest that you ever get. If you have a parabola that opens down, the vertex is the highest you ever get. So again, because of the way parabolas are shaped, the parabola's vertex will either be a minimum or a maximum value. And when they ask you for the maximum or minimum value, they're asking you for the height. So they're asking you for the y coordinate. So if I ask you to find the maximum y value of a graph that is a quadratic, I'm asking you to find the y value of the vertex. So maximum means vertex. That's what we want. So we need to use our x equals negative b, so that's negative negative 2 over 2 times a, which is negative 1. This is 2 over negative 2, which is negative 1. That is not what they asked us though for. That's just the x value of the vertex. They want the y value if you want to find the actual height, which is what we mean by maximum or minimum. So the y value here would be negative negative 1 squared minus 2 times negative 1 plus 3, using my equation right here. So this is negative 1, because negative 1 squared is 1, plus 2 plus 3. So this is 4. So the maximum y value of this specific graph, the highest it will ever get on the y value axis, is 4. Now, where we can use this in the real world is usually dealing with maximums and minimums of projectiles. So here's a couple examples of that. It says find maximum height. So an object is thrown upward from the top of a 100-foot cliff. That's why this is the like the C. That's how high up we started. Its height in feet above ground after t seconds is given by this equation. So negative 16t squared plus 10t plus 100. Find the maximum height of the object and the number of seconds it took for it to reach its maximum height. So since t has to do with x here, when we do our vertex formula, we'll get the time first actually. The maximum height has to do with the y, or the f of t. So we need to do, since they said maximum, we're doing a vertex. So this would be t instead of x equals negative 10 divided by 2 times negative 16. So that's negative 10 over negative 32. We'll reduce that fraction, divide it by 2. That's 5/16. And this is being measured in seconds. So it took 5/16 of a second for this object to reach its maximum height. And that height, since we have to plug it in as a fraction, we'll have to work this out. And you can use your calculator, but I'm going to work it out by hand. Plus 10 times 5/16 plus 100. You have to square this first, so that's negative 16 times 25 over 256 plus 50/16 plus 100, because 5 times 10, that's how I got my 50. 16 actually reduces into 256 and leaves you with a 16 in the bottom. So that's negative 25/16 plus 50/16, plus we need this guy to also have a common denominator. So if we put that over 1, we can times it by 16/16. Or we could, yeah, we're going to do it that way. So this would be 25/16 for the first two, because we can add those together. This is 1600/16. So this is 1625/16. Now, most of the time we wouldn't leave an answer like this. So the question becomes, is decimal appropriate? Is mixed number appropriate? If you're doing a mixed number, you would do long division, and you'd say 16 goes into itself once, bring down the 2, it goes into 2 0 times, bring down the 5, it goes in 1 time, and we would subtract, and that is 9. So this is 101, because that's how many times it went evenly, and 9/16. And that would be how many feet it is in the air. Now, if the directions say you can go to decimal, then you would have just had on your calculator 1,625 divided by 16 and turn that into a decimal. So it really just depends on what the directions say. All right, so let's do another one. So a baseball is hit into the air and its height h in feet after t seconds can be calculated by the formula h of t equals negative 16t squared plus 64t plus 2. What is the height of the baseball when it was hit? Now this is not max height. This is just what was its original height. Original height is when your time is 0. You just hit the ball. So it's that immediate first instant. You haven't even had a second pass. So we're going to hit, plug in 0 for hit the ball. And what you'll notice is that just leaves me with 2. So this ball was 2 feet in the air when it was hit. Now we want to know the maximum height that the baseball gets to. So that's the vertex. So remember we have to do t is negative b, so negative 64, divided by 2 times a, which is negative 16. That's negative 64 over negative 32. That's the 2 seconds, not 2 feet. That is not what we're looking for because remember the vertex maximum height is the y-coordinate. So we need to plug in 2, and this is h of t, sorry, into our function. So negative 16 times 2 squared plus 64 times 2 plus 2. That's 4 times 16, that's negative 64, plus 128 plus 2. That would be 64 plus 2, which is 66. So this baseball reaches a maximum height in the air of 66 feet. Okay, and then the last portion of section 11.1 is about what we call basic transformations of graphs. This is just a picture. I'm not going to read all of this to you because honestly it's confusing and I summarize it better. This came from the textbook, but I'm going to summarize what we're going to talk about in a box down below, or at least in a list. So this is the original x squared, this pink graph. If you times x squared by 2, it grows faster. So what that means is that this green graph has been stretched. It actually looks like it's skinnier than the pink graph. We call that narrower to be PC. So this green graph is narrower. If you take the x squared graph and you cut it in half, notice the graph is growing slower. It's not getting as tall as fast. So this is what we call being compressed. You're being vertically squished down. So this right here is wider than the original graph. And the same thing happens like this, but the only thing difference is we made a negative on each of the numbers. So the numbers still affect the graph the same way. If the number is 2, it's going to be narrower. If it's a half, it's going to be wider. But the problem is now it's been flipped upside down because of that negative leading coefficient. So that's all we wanted you to see from that picture. I have my own summary other than that box, so but we can read through this one. It says, if you have the graph of y equals a times x squared, that means a constant just in front of x squared. You don't have bx and you don't have c. The vertex will be 0, 0. The axis of symmetry will be at x equals 0 then. If the graph opens up, if its a is bigger than 0, it'll open down if its a is less than 0. So again, we knew those things. It's wider than the graph of y equals x squared if the leading coefficient is between 0 and 1. So if your leading coefficient is a third, a half, 4/5, 2/3, anything between 0 and 1, that means you're going to get a wider graph. It is narrower than the graph of y equals x squared if the a is bigger than 1. And notice they're putting absolute value because we ignore the negative sign. Like when I look at this one down here, I see a 4. The negative doesn't tell me if it's wider or narrower. The negative tells me if it's opening upwards or downwards. So this gives me 2 pieces of information. So since this is greater than 1, this one's going to be narrower than the original x squared graph. Okay, so first thing we're going to do is graph x squared on the graph, because we want to use it as a comparison, because it does say we're going to graph both, and we already know how to work x squared. This is just -2, -1, 0, 1, 2. 0 squared is 0, -1 squared is 1, -2 squared is 4. 1 squared is 1, 2 squared is 4. So just as a reference, we're graphing this guy. 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4. Okay, so that's my original graph. Now, this one right here, we're going to talk about because it has a transformation from the original. First of all, there's a negative in front. The negative in front means that it's going to open down. There's also a 4 in front, and 4 is bigger than 0, so we're going to be narrower. than x squared. Now, I didn't need any of that to graph it, but it helps if you can describe it, and we're going to ask you to describe it. So again, put in 0, -1, -2, 1, and 2. If you put in 1, you get 1 squared times a -4, so that's going to be -4. Put in 2, you get 2 squared is 4 times a -4 is -16. 0 squared is 0 times anything would still be 0. -1 squared is 1 times -4 would be -4. -2 squared is 4 times -4 would be -16. So you notice this graph gets way bigger numbers than the original. That's why it's going to end up narrower. So we still have 0, 0. -1 is down at -4. +1 is also at -4. And then those -16s would be way off down here because we don't even have that on our label. But this is 10 at the bottom. So notice this graph is much narrower, or sometimes people like to say skinnier, than the one above it. And again, I'm not able to draw this really great because of the grid lines, but that's all it is. So that's the comparison. Now, are there other comparisons that can be made? Of course there are. So here's my summary. It says if you have your ax squared plus bx plus c, if a is positive, we know the parabola opens up. If a is negative, the parabola opens down. If the a is between 0 and 1, your parabola will be wider. If your a is greater than 1 out front, your parabola will be narrower. If you have this type of setup, your y-intercept is always at c, because if you plug in 0 for x, those first two terms go away. So that means that if you knew what this graph looked like, which most of the time we won't, this is just shifted either up or down from this standard form right here. So again, we're not worried about that. We just want to know that it's the y-intercept. Also, we know a and b are affected by to tell us the vertex. So the x-coordinate of the vertex is the -b/2a. The axis of symmetry is also that as a vertical line. Okay, so we want to do just one last graph, I believe. Yeah, because this leads into the section we're going to cover on Monday. So we're going to answer some questions about this one. It says, does the graph open upwards or downwards? Well, that's determined by if the leading coefficient is negative or positive. So since my leading coefficient is negative, I'm going to say that this one opens downward. And I'm going to write a note, leading coefficient is negative. Okay. Is the graph wider or narrower? That has to do with the number in front, not the negative sign. So 1/4 is between 0 and 1. Anytime the number is between 0 and 1, you're actually going to have a graph that is wider. If it had been like 5 or 6, which is greater than 1, then we would have been narrower. Find the axis of symmetry in the vertex. You find them both using the -b/2a, except this one's a little more complicated. This is -1/(-1/2) if I reduce the denominator. We'll times top and bottom by 2 to get rid of that. So that's -2/(-1). So that's 2. So that is my axis of symmetry. If you want to go ahead and write that down, axis of symmetry, x equals 2. To find the vertex, you need another piece of that. You need the other part of the ordered pair. So we have to plug +2 back into our function, because that was what we got for our y or our x value. So this is 4, that's a 4 on the bottom, that's going to cancel, so that's just going to be -1. So the 4's here are going to cancel out and leave me with -1, +2 -1, this ends up being 0. So it's just by coincidence that it's an x-intercept. Find the y-intercepts and the x-intercepts. Well, to find the y-intercept, you plug in 0. Remember, for all of your x's, I am using this version right here because I can see what the equation was. But that's going to be -1, so that's the ordered pair 0, -1. To find your x-intercepts, you have to set the original function equal to 0. So to find x-intercepts is different than to find y-intercepts. So -1/4 x squared plus x minus 1. I would go ahead and multiply everything by 4 on both sides to get rid of that fraction. So this would be -x squared plus 4x minus 4. And we're going to try to factor this. I'm going to pull out a negative. That would be x squared minus 4x plus 4. And then we would set this as factoring. It's x minus 2 times, so x equals 2. Now that makes sense because our vertex is x2. So if it's the lowest point on our graph, or actually highest point because this one's a negative in front, then there should only be one x-intercept if it's an x-intercept. There shouldn't be another one. And we'll talk more about that specifically on the Monday lesson because that has something to do with something called the discriminant, which we will define and when we do the quadratic formula. So let's plot what we know, or actually let's put down what we know. We know that our vertex is at 2, 0. We also know that we want the points 1 and 0. We already know 0 because we plugged it in. That's our y-intercept. And we'll want the points for 3 and 4. So if we plug in 1 into the original, so -1/4 times 1 squared plus 1 minus 1, that is -1/4 plus 0. So it's just -1/4. And then I shouldn't have to do anything if I've got my correct vertex, because remember that should match on the other side. So 0, -1. 1, -1/4 is really tiny, but it's just right on the other side of the x-axis. 2, 0. Then we have that one and that one. So notice this is a very wide parabola, wider than the normal x squared. Okay, and it's opening downward, it's wider, its vertex is 2, 0, -1 is a y-intercept, 2, 0 is the only x-intercept. So the only other thing if you wanted to do it is if you could, if they ask you to, you could sketch in the axis of symmetry. And they don't always ask you to do that, so it's just if it's asked. All right, so that's the end of this video, and that leaves us with just section 11.3, 11.4. It's kind of a combo section to cover in class on Monday. I will have a worksheet that we will start class off with on this to help you make sure that you understand it. So we'll start class with that worksheet, do a few together, and then that way the concept is good and solid, and then we'll cover the new stuff. All right, see you in class on Monday.